Thank you. I wish I could be with you today in person, but unfortunately my flight was delayed and there was no way for me to get there in time. Brandon Suarez will be with you in my place, and you will be in very good hands with Brandon. The DASC organizers graciously allowed me to record this video for you at home, so I can still talk to you all. Because I am a video, feel free to stare off into the distance, yawn, stretch, look at your phone, make comments to your neighbor, or even take a nap, because I will not know the difference. I attended DASC in 2018 in London. I still have the pint glass, thank you. It's one of my favorite pint glasses. And I was really struck by what I experienced. Conferences I had attended up until that point were either too academic, focusing on abstract, futuristic concepts with little consideration for how something would be implemented in the real world, or they were too commercial, trying to sell you yesterday's technology. DASC occupies this really interesting space in between, focusing on what we can do today and in the very near future, with an intense focus on pragmatism and safety that I think is really healthy. Reviewing the program, I'm really excited by the agenda this week. I wish I had more hours in the day to read all of these exciting papers. I wish I was there. There's one session that jumped out at me, and I don't mean to pick on anybody or anything, but I think this title perfectly captures the spirit of pragmatism and safety and what excites me about DASC. It's called Enough Fluff, Returning to Meaningful Perspectives on Automation. I read this and went, yes, this is what we're talking about. I hope it lives up to the title. No pressure. I want to talk for a bit before I get started about Reliable Robotics. We started Reliable out of a shared vision for making aviation safer and more accessible through automation. At the time, and perhaps this is still true today, we saw a gap in the industry between what was currently available, yesterday's technology, and the futuristic concepts that were being pursued by others. We thought there was a space to find a middle path, to take what already existed, add a little more incremental innovation on top, and create something new. As you may know, our first project is to certify an advanced autopilot for the Cessna Caravan, a popular fixed-wing aircraft capable of carrying about 3,000 pounds or 13 passengers. We chose the Caravan for 3 reasons. 1, we wanted our technology to have an appreciable impact on safety from day one. Any Caravan pilot will tell you they do real flying. These aircraft operate in more challenging conditions than most other commercial aviation aircraft, at lower altitudes, in more serious weather conditions, and they do so single pilot. I have tremendous respect for Caravan pilots. These are true professionals doing one of the more difficult jobs in aviation. So we felt that an advanced autopilot, one capable of running these operations end to end, would bring immediate safety benefits to these operations in terms of alleviating workload, improving flight planning, and less overall risk when operating in lower visibility conditions. Second, we wanted our first product to have a public benefit as well, and the Caravan stuck out for us because of the essential role it plays in providing access to rural communities and harder-to-reach corners of the planet. The town where I grew up, for example, if you wanted to overnight a letter or receive any kind of overnight package, the only way it was going to get in and out of there was on a Caravan. I don't think many people realize how the essential role that these types of vehicles play for rural communities. I may be a bit biased coming from a smaller town, but I think the promise of aviation, when you think about the promise of aviation and the benefits it can provide to society, I believe we should be thinking about the benefits it can provide to everyone, not just people that live in big cities or near major airports. Third, being a business, we obviously needed to start somewhere where there was a strong customer need. And the demand for automation of small aircraft is very high. And perhaps not for the reasons you may think. I get comments all the time about costs being a driver, and that's certainly part of the equation, but it's not the number one reason air carriers want more automated aircraft. It's about improved safety. It's about increased flexibility. We chose an approach to automating the Caravan in a way that we feel strikes a balance between innovation and cautious pragmatism. Our system operates within the existing airspace framework and borrows heavily from existing accepted technology standards and procedures. I honestly don't view what we're doing as all that special, at least from a technical perspective, because I feel that we are merely pushing forward along this steady march of safety improvements that we've been at now in aviation for over a century. And this is what I want to focus on for the talk. Innovation in other industries tends to get talked about as something revolutionary or moonshots, but aviation just doesn't work that way. What makes aviation special is the steady drumbeat of progress, continuously improving and evolving to make it safer. And I feel like at Reliable, we're just continuing this tradition. Companies like ours exist because we get to benefit from the work of everyone else. In essence, we're standing on the shoulders of giants, so to speak. Looking back over the last century, aviation has seen remarkable advancements over time. One of the first problems impacting aviation safety was navigation at night, and one of the first solutions was remarkably simple: light beacons. This concept was borrowed from sea navigation, but it worked well and went a long way towards preventing nighttime accidents. One aspect of this that I thought was interesting or really clever was that in some places the light would change color based on the viewing angle, so you could tell if you were off course. And if the light disappeared, what does that mean? Well, it means there's either a cloud or a mountain in front of you, and either way, you need to turn around and go the other way. Light beacons were eventually replaced by radio navigation, initially non-directional beacons and then later VOR, as these were more robust and less susceptible to interference from clouds. And then instrument landing systems were created to provide more accurate guidance, getting the aircraft back to the airport environment, which was then, of course, that was built on previous radio navigation technology. Many of these concepts and technologies and procedures for ILS then carried forward into Autoland. And Autoland systems were developed in earnest in the 50s to address safety concerns with low visibility operations in harsh northwestern European winters. This early work spearheaded concepts of target level of safety and fault tree analysis, ideas and processes we use almost everywhere now, and in many industries, not just aviation. Autoland also drove some of the first work in triple redundant avionics, another safety and reliability enhancement that's used for many subsystems in aircraft today, not just Autoland. One of the first DASC papers, actually, describes a modified 737 capable of 4D flight planning and control. And this vehicle was later part of NASA's Terminal Configured Vehicle program in the late 70s. By the way, they called this system the Advanced Electronic Display System, or ADEDS, which I think is a terrible acronym for a safety-enhancing system. Or maybe the engineers didn't want their prototype code to go into production, so they gave it this name. I don't know. But anyway, this system was capable of complete flight from takeoff through landing, and many of the techniques it describes builds on previous work that was done for the development of autopilots and Autoland systems. And again, the motivation was to maintain and increase safety. Terrain avoidance and traffic avoidance systems then built on that work, driven by a desire to further reduce flight into terrain and mid-air collisions, which were shockingly common in those days. I'm oversimplifying a bit, obviously, but I'm trying to make the point here that when you look at what we have today, we have now an incredibly safe air transportation system because of this long, steady stream of incremental safety improvements. Every safety innovation has built on the last. Even GNSS, GPS, WAAS, these systems really build on what had existed previously. Sure, the underlying technology is very different, but the methods and procedures for getting them into aircraft and the airspace, you can trace back to the earliest navigation systems. You hear people make comments about pace of innovation in aviation being slow or too slow. I just don't see it that way. Sure, I'm an engineer and I'm an entrepreneur, which makes me an impatient engineer. Things can always be done faster and better, but I don't see aviation being slow for the reasons many people describe. Aviation, and I mean civil aviation, is slower not because it takes time to adopt new ideas, but because aviation is one of the few industries where you don't make changes unless you can make a solid case that the changes make things safer. But it's not a single criteria that decides what's safe or not. It's a rich set of interconnected organizations, tools, and processes that tie it all together. It's kind of like a Swiss cheese model, but on a macro scale, or you could think of it maybe as interlocking gears. And aviation's pragmatic focus on incremental safety improvements, I'm talking about this, it's not so much a mantra, but it's really the result of all of these systems working together, all of these interlocking gears working together. And so we have many new incremental safety improvements that are right in front of us now, and many of which we're going to realize here in the coming years. I think this is a really exciting time to be involved in aviation. I want to mention a few of these now that are really exciting to me, not just for their long-term potential, but also the safety benefits they can bring to aviation in the nearer term. So starting with single output navigation systems that are 10 to the minus 8 or greater. These systems are right around the corner, and this has been a big focus for us at Reliable, as this will be a core enabling technology for many things in the future. What I mean is a navigation device, or rather an ensemble of devices that give all other aircraft systems position, orientation, velocity, etc. But they do so with sufficient robustness and redundancy that it can be trusted for all critical operations. The safety benefits of such a system will be tremendous. I think about it just as a pilot. You're trained to check and cross-check your instruments against one another, spot the faulty instrument. Don't you want the system to do that for you? Just tell me what I can and can't trust, or better, just be one fault tolerant, and instead of telling me what I can and can't use, tell me when it's time to land, because I'm one more fault away from having a bad day. That's really what you want. 4D terrain-aware flight planning is also almost here. We're so close to realizing the vision of the Terminal Configured Vehicle program. We will very soon have systems that allow you to fly a fully specified 4D flight plan from takeoff to touchdown in a certified way, while still accommodating real-time changes to that plan to meet dynamic traffic and weather requirements. This matters a lot because controlled flight into terrain is still the number 2 cause of fatal accidents in general aviation. And commercial airliners are not immune from this either. We have the technology. People don't need to die. And then once you have 4D flight planning, now you can build a system that continuously engages the autopilot through all phases of flight. What I mean is you click the autopilot on at the hold short line, and you don't click it off until you're off the runway at your destination. I was just talking to Art, and I wish I was there in person so I could gesture in Art's direction. We were just talking about this over the weekend. Building this type of autopilot is not hard. There's no fundamental research problem to solve. It's just millions and millions of little details. But this matters a lot too, because loss of control is the number 1 cause of accidents in general aviation. And commercial airliners as well are not immune from this either. This also matters a lot for pilot training, because simplified flight interfaces will make knowledge transfer between aircraft much smoother and thus safer. Autoland without infrastructure at the airport is another very exciting area. There are a lot of proposals out there right now, some I saw in this DASC program, that use all varieties of new sensors or combine sensors with existing navigation sources in new ways. Being able to perform a Cat 3C autoland on more aircraft to more airports is going to make a huge difference when it comes to safety and availability of aircraft operations. For commercial ops especially, I'm excited by the number of airports that this will open up and the massive number of delays due to weather that will be prevented. Conversely, auto takeoff is an area where we're extremely close. Takeoff actually isn't the hard part. Most aircraft want to fly after all. The tricky part is takeoff rejection. But this is where automation can really shine. Engine and other critical system parameters can all be monitored hundreds of times per second and make a decision much faster than a human. I was just watching a video recently where a GA pilot was analyzing a rejected takeoff, and he admitted it took him a whole 4.5 seconds to realize his engine pressure was in the yellow. He was fortunate he caught it before taking off, but he ate up hundreds of feet of runway in the process. And similar to CFIT and LOC, aircraft misconfiguration on takeoff is also a common cause of accidents. And auto takeoff will go a long way towards preventing these types of accidents. In the near future, we'll also have auto taxi. Many of the building blocks are almost ready for use in the current airport environment. Navigation databases with taxiway data exists. High-precision navigation systems are almost ready. You take these and you combine them with the same sorts of components and control techniques for auto braking following landing, and you're almost there. And insurance companies are going to love it. Certified bidirectional communications for command and control, C2, is another area where we're very, very close. We have many systems for communicating with aircraft today, but we don't yet have anything that allows an operator to remotely command an aircraft and remotely command that aircraft in a way that would alter its flight path. CPDLC is close, but this isn't designed for urgent communications. This type of system would make air traffic control communications much more robust and less open to misinterpretation. This would also make communications more secure and allow us to begin to layer new, more sophisticated features on top. If I was in the audience, I would say, raise your hand if you're a pilot and you've ever misinterpreted an air traffic control command and you wish it was just on the display in front of you. DAA, or detect and avoid technology, is another key area. The first challenge here was defining what the D and the A actually mean. RTCA 228, Special Committee 228, and countless research teams spent years going back and forth on how to define aircraft separation or what it means to remain well clear. Going back to one of my earlier points, this is partly why things in aviation take as long as they do. In order to solve a problem and do so in a way that maintains or increases safety, you first need to meticulously define the problem you're actually trying to solve. You don't just jump in with a solution. I think it's really exciting to think about what you can do when you start to combine all of these components that I just described. Imagine an aircraft with 4D flight planning, auto land, auto takeoff, auto taxi, advanced communications, and new sensors and avoidance methods to maintain well clear. Well, now you don't need the pilot in the plane anymore. You can remotely pilot this aircraft. And think about how much safer this is going to be. If you're operating the aircraft from a control center, you can have people cross-checking decisions. You can take crew resource management, CRM concepts, and scale that up to a team of people. You can borrow techniques from air traffic control management. You can have caution and warning systems that alert other pilots. Crew rest and fatigue considerations can be managed in an entirely new way. You can even have shift changes in the middle of the flight. Remote piloting is going to drive a lot of improvements to aviation safety, some of which we probably can't even imagine today. I also want to touch on digital flight. This idea is flown under a lot of different banners. Some call it free flight or UTM or advanced air traffic management. But the core idea is the creation of new operational rules that use the latest advancements in technology to rethink the airspace and drive higher levels of safety and efficiency, much how the airspace was redesigned for the jet age. I feel this is incredibly important work, and much more work will be required if we are to realize this vision. We especially need to consider how we're going to integrate existing traffic operations under VFR and IFR with remotely piloted aircraft at scale. To my point earlier, aviation changes are driven by safety imperatives. So it's on us, the community, to show that this new system will in fact be safer. I would be remiss not to bring up security as well. Combining all of these components is going to raise legitimate concerns about the security of these operations, potential vulnerabilities, and potential for misuse. There are many building blocks to draw on from aviation and other industries, but every new use case is going to introduce new threat factors that will need to be considered. And this community will need to face them if we are to obtain public's confidence in these systems. I believe we are on the cusp of a great transformation. And I will be so bold as to compare it to the internet. Yes, I'm going to go there. Bear with me. People talk about the internet as some kind of revolution. I think you're picking up on my theme here. It really wasn't. The internet was the culmination of almost a century of incremental innovations in electronics, transistors, algorithms, programming languages, and communication systems. When I was a teenager, in 1992, O'Reilly published the whole Internet User's Guide and Catalog, if anyone remembers this. They compared the World Wide Web, what we now think of as the Internet, to Gopher, which was really just a fresh take on FTP. And at the time of the web, HTTP and HTML really didn't seem like anything all that special. It was just an incremental update on prior technologies. I think very few saw how this new web thing was going to take off and radically change the way that we live and work and communicate with one another. And I think we're at a similar stage right now with aviation. Looking back, countless numbers of small incremental improvements have made aviation safer. But these incremental safety enhancements are about to be combined in new ways that's going to make aviation, like the web, radically more accessible to more people. I hope you found my perspectives on automation meaningful and not too fluffy. At the risk of introducing a little fluff, I do want to stress how important the work this community is doing and how much we value it at Reliable. Fully automated aircraft are going to be aviation's internet moment. Think about all of the additional air traffic we will be able to drive into the air, the efficiency gains and the improvements to affordability that we'll get. Think about all of the additional people that will be able to utilize the air for work and for travel, and how much smaller this is going to make the world feel. Think about the lives that will be touched, the experiences that will be had, and the families and loved ones that will be connected. Okay, I'm sorry for getting a little fluffy, but aviation is just such a beautiful invention, and the collaborative nature and focus on safety is equally beautiful. I'm proud to be part of it. On behalf of Reliable Robotics, thank you to all of you for the work that you do, and thank you for allowing me to speak to you today.